Okay, the recording has started. So thank you everyone for joining the workshop. We are very pleased to organize this particular workshop on everything you need to know about final year design project IEEE 400 or IEEE 400. So those who are currently pursuing this project particular course and also those who will be pursuing this in near future for both group of students, this is very important workshop and it will be conducted by our very own Professor Dr. Abdur sir. So thank you very much, sir, for your kind time and sharing your knowledge with us. So I hope that everyone of the students and also us, the faculty members, will be benefited to understand and the evaluation process of this final year design project. So we have among us with us a few of our faculty members as well, Professor Shariat Khan sir, Dr. Tawhidur Rahman sir, we have Dr. Mustafa Habib Chaudhary, and we expect that we will have our head of the department and Firoz sir and other respected colleagues to join with us very soon. So I think it is already 10 minutes past. So without any further ado, I would like our facilitator, Dr. Abdur Razzak sir, to start his presentation. Thank you very much.
Thank you, Dr. Kafi, for arranging these workshops under the banner of IEEE IUB student branch. First of all, dear respected colleagues and the students, this is a very important workshop, I think, and this is necessary not only for the students, but also for the faculty members. We have to understand this very much before starting the final year design project, that is IEEE 400 or the ET 400. So today I will try to discuss from A to Z of this final year design project, from where we have to start and what are the processes, what are the teaching learning methods, what are the process of conducting research or completing or implementing the project, and then the evaluation. So hopefully this will be very helpful for the students who have already registered and who will be going to register in the near future. So Dr. Kafi, would you please stop sharing? Thank you very much. And I will first start with the materials, where the materials are available, because today I don't have any PowerPoint slide, because I will show A to Z the materials which we have available, and especially in the IEEE website. And those who are not available, I'll tell you how you will get that. I'll try to guide from the beginning. Okay, first of all, we have to log into IEEE website. Okay, just IEEE.iub.edu.bd. So just log into this site. I think this is visible to you, right? Anyone?
Yes, sir, it is visible.
Okay, thank you. So just log into the IEEE website and then go to this menu bar, and you can see the download menu over here. You can find the download for faculty members, download for the students, and download for alumni. So the student should click here. For the faculty members, we have to go here and here for our materials. So let's go to the materials for the students. These are also materials we have to learn. We have to know. The faculty members also should be known to these materials. So you can see the IEEE ET final year design project. The materials are here. So documents, you can see the downloaded versions are here. So starting from the IEEE 400 manual. So although it is written IEEE, the ET is the same. So you can see you can download from here. So you can also download the IEEE 400 application form. So first of all, you have to go to A to Z. So I'll discuss this one first. Then I'll go to the IEEE 400 application form, then the IEEE 400 project proposal form, then we have the sample of course, and then progress report template first term, then sample of the first term, then the progress report template the second term you have available. So we have also the IEEE 400 final report template, and then the final report sample is also there. 400 peer evaluation form. This is necessary for the students to evaluate your group members. So I will discuss about the complex engineering problem and complex engineering activities along with the knowledge profile. This is very important to understand both for the faculty members and the students to implement the project. And then there is an example already given here. I'll discuss this example. And then we need the 400 presentation template, first term, second term, presentation template of the final term, and presentation sample of the final term is also given here, and 400 project demonstration poster template. So you have to demonstrate the poster at the end of the semester, at the end of your project, final semester. So the template is there, and also there is a sample poster here. So everything is here. So let's start with the very beginning one. Along with this, we have a course outline. Actually, course outline consists of all these materials over there. So I'll also guide that one also. So first look at the IEEE 400 manual. Okay, so I'm not downloading from here. I have already downloaded. So everything I can show from here. So can you see this?
Yes, sir.
Okay, so IEEE 400 final year design project manual. So IEEE 400 final year design project manual is the same one. Okay, just replace the ET with IEEE. That's it. So this is the guidelines for the final year design project. The objective of this manual is to provide a clear idea about the strategy for developing a final year design project, right? It also guides students and also the faculty members about the undergraduate final year design project. So let's look at the structure. So we know that the final year design project we have to complete with 1 year. That means in 3 terms. So for the first term, we are supposed to start with this one. We have to have a group formation, right? Your first duty for the students to form a group and the project selection. So at the moment, probably you cannot select the project title, but at least you have to set your mind in which area you want to pursue your project. Whether you want to pursue your project with the electronics, or for example, with the power and energy, or for example, with the communications, or for example, with the artificial intelligence, okay, VLSI, whatever it is, you just set your mind, okay, and with the same people, you form a group. Second thing is that you have to submit a group proposal. I will show you the proposal form, and actually, during this group formation and before the group submission of the group proposal, actually, there is another step. You have to submit the application form to the respected supervisor. Okay, respective supervisor. You have to submit. If the supervisor agrees, then actually that you have to submit to the department through the supervisor. So if the supervisor agrees, then the department knows that how the group is formed and who are in that group. If the supervisor agrees, then you can proceed on. Then you can start your final year design project, and then in the very beginning you have to submit your group proposal, and then you have to submit the first term progress report submission at the end of the first term. progress, and then the first term progress report submission. You have to present it, and then you have to submit the report. So this is all about the first term. In the second term, just we have to copy these two. That is, we have to repeat this last two. That means you have to submit the progress report, and also you have to present it. In the final term, of course, you have to submit the final report and you have to present it. But before that, or probably after the presentation, there is another process, which is you have to demonstrate your project, whether the project is simulation based or theoretical model based, or for example survey based, or for example the experimental based. So you have to demonstrate it in front of the industry advisory panel and in front of all the supervisors and all the faculty members and the guest. So if we summarize the process, then look at the step. The first step is selecting a supervisor, project supervisor, right? And the second step is submitting the final year design project application form. So you have to actually submit this application form through the supervisor to the department, okay? So that means you have to have some personal talk with the supervisor, okay? So that you can find a very good supervisor with your topic or with your area of project. Third one is implementing the project, right, in three terms. So what are the steps over here? The steps over here, that selecting the project title, okay, after identifying the problems. Of course, you have to follow the guidance of the supervisor, and you have to take advice. Also, probably your supervisor will take advice from the industry advisory panel, and they will mutually set the project title. Okay. The second one is submitting a project proposal. So you have to submit the project proposal to the department office through the project supervisor. So during the first term, you can submit it, no problem. But after then, you have to submit and present the progress report, right, for the first term. And then you have to submit and present the progress report for the second term, and then demonstrate the project after the final term in front of the industry advisory panels and all the supervisors and the guests available over there. And then depending the project, that means you have to present the final term progress. That is, this is actually the overall of your project you have to present. So the exam date or the presentation date will be normally at the end of each term, okay, and will be announced by the department. So and then you have to submit the draft report, okay, draft report, that is the final report to the project supervisor. The project supervisor will check the report and then back to you. But make sure that there will be grading and there will be plagiarism checking for this one. That is similarity index check, whether you have copied from somewhere or not. Make sure that the similarity check index must be less than 30%. Then you will get the full marks. Otherwise, marks will be distributed. I will show you later on. And then you have to submit. Once it is finalized, okay, from your supervisor, then you can go for the hard binding. So you have to submit 3 copies of the hard binding of your final report, 1 copy for the supervisor, 1 copy for the department, and 1 copy for IUB library for archives, okay? And then you will get the final grade. Okay, so before leaving this portion, okay, so if you have any question regarding this step, if you don't understand any step, you can ask questions. Anybody? Just unmute your mic and you can ask question. You understand all the steps?
Yes, sir.
Yes.
Okay, clear?
Yes.
Sir, I
Yes,
kind
sir.
of have a question.
Shia?
Sir, in case of plagiarism,
Yeah.
hey, the faculty members are going to check with a software. For us students, is there some way we can check that we didn't copy exactly like it's supposed to be in our own words, but
Yeah.
is there somehow we can cross-check so that we can make sure that we are not making any direct copies?
No. Normally, this is your responsibility. If you want to check with a commercial software, for example, right? So because you guys knows whether you have copied or not, okay? Because normally you have to write your own sentences, your own
Yes, sir.
language.
But
You have to explain.
sometimes even if we try to write in our own words,
It
something.
is very unlikely. It is very unlikely that the whole sentence will copy. Some words may be matched, but
Yes,
not
sir.
the sentence.
Okay,
Okay.
sir.
So the plagiarism checker normally check the phrases, not the words. Okay. Normally the phrases. So at least half of the sentence or the whole sentence. Okay. The plagiarism checker will not word by word. Okay. Not a single word will touch because all the words are actually common. Okay. So don't
Yes,
be afraid of that one. Okay.
okay, sir.
Only thing is that
Understood, sir.
make sure that you are not directly copied the sentences from the available materials. That's it.
Just to add with what Professor Razzak sir has said, is that if you really write down by yourself, it's true that there are some phrases, standard phrases and keywords that you cannot avoid, and those will be, marked as similarity. But that's why the bar has been given as 30%, not 0%, right? So if you write down by yourself, very unlikely that it will go more than more than 30%. Okay, the similarity index will come obviously less than, less than 30%. So I think there is no problem with that. At this moment, the authenticate, only the faculty members through IUB library, we have access to that. The students do not have access. If you want to have access, then you have to buy your own license. So it's not free. Thank you.
I want to add, can you hear me? I want to add another point here. Can you hear me?
Go ahead,
Yeah.
sir.
Yeah.
Yes.
So this is for the students. Regarding the plagiarism check, there's something called self-plagiarism. So suppose you have a paper published in an IEEE conference paper, for example. If you're trying to copy the method section exactly from that paper into your report, IEEE 400 report, that will be caught. So just because you wrote those sentences in your own paper, but once you publish it, you have given the copyright over to IEEE. So what happens is, even your own sentences, you should not be copying it word for word from a published material. So if you have a paper published in a journal or in a conference proceeding, you still cannot copy an entire section from there just because you wrote it. Because once you publish, you have given up your copyright
To others.
copyright privileges to the publishing authority.
Yes.
But the other way around
Yes,
is
sir.
not true, which means that if you already published your thesis first, and then from your thesis you want to publish in a publisher like IEEE Explore or wherever, then the other way around is okay. You can actually copy your thesis material into your paper, but not the
Yes.
other way around. Okay.
Yeah.
So thank you.
Okay. Thank you very much. So any other question regarding these steps?
Sir, I had a question.
Yes. Sure.
Sir, it may sound obvious, but how do we go on selecting a project supervisor?
Okay. So selecting a supervisor means I'll come back. Okay, one by one. The procedures are here. Okay, I'll come to your question. Any other question? Okay. So look at this one, the project supervisor. Okay, so selecting the project supervisor means actually students completing at least 100 credits. Okay, 100 credits can select their supervisor from the department of IEEE based on their research interest. So go to their website and go to the website, IEEE website, and faculty profiles, see the faculty profiles, so you can see their research interest. Okay, so from there, actually, you can find their research areas. Okay, otherwise, you can discuss with your academic advisor, and also you can discuss with the faculty members to know the details about their research field of interest. Okay, so students may also select their supervisor from outside IB department, but in that case, from outside, you have to take permission from the IEEE department, and you have to choose a supervisor, main supervisor from the IEEE department, and co-supervisor from others. Okay, in such a way you can also proceed on. Okay, is that answer suffice your question?
Yes, sir.
Okay, so then you have to write a project proposal, right? Project proposal. I'll show you the form, and then you have to conduct your project. Then defending the project. Yeah. Okay, how to write it, what will be the presentation title, everything in the format already there, but you should go to this examination committee. So the examination committee members will be assigned by the head of the department, but normally the practice so far is one or more external member may including the panel from the industry advisory panel. May be included in the committee. Otherwise, all the faculty members are in the examination committee members. You have to write a report. Of course, the report here is the guideline that approximately this is not exactly fixed. Approximately 40 to 60 pages. The report, including the appendix and the preliminary pages. Okay, student must write their report according to the format. Okay, the format is given, and a template of the final year design project is available in the website. Okay, report submission, as I said, that you have to submit the final copy, 3 copies, 1 copy each for the project supervisor, IB library, and IEEE department, and a soft copy of PDF format. Okay, you have to submit it. Plagiarism. Let's check. We have already discussed that you don't need to consider these things if you write everything by your own language. So you are in safe. Okay, so don't copy each. So how we will mark it? Normally, once you submitted the draft copy, we will check it through a plagiarism checker. Especially this is the certificate. Provided by the IEEE. So you can see that the plagiarism index should be less than equal to 30%. So if it is 31 to 40%, so less than 30%, you will be given full marks. Okay, and these marks will be given. You have submitted the draft copy. Okay, this is the copy. Or for example, if you submit to the draft copy to the supervisor will check, and then you submit it to the department. Once you submit it to the department, that is the final. Okay, that is the initial final, not the final copy for the hard binding. That is the initial final for marking on the similarity index. Okay, so if it is less than 30%, you will get 100%. Okay, if it is 31 to 35%, you will get 80%. So similarly, if it is greater than 60%, you will get 0. Okay, so you will get 0 on that initial submission, but you will be given a second chance to correct the report. Okay, and if you submit in the second chance, you will be given 50% of this on the original marks. Okay, if it is in the second chance, if it is less than 30%, you will give 50% marks. If it is 51 to 60%, you will get 10% marks. And once again, if it is greater than 60%, you will get, of course, 0. 0 by 2 is also 0, right? But for the third attempt and onwards, you will be given no marks. You will not get any marks. But make sure that the similarity index for the hard binding must be less than 30%. That means you are not getting any marks on this report, particularly on the plagiarism checking part. Exactly, I don't know how much percentage is there. I will show you later on, but you will not be given any marks. But make sure that you have to have less than 30% on the plagiarism checking. That means similarity index for the final hard binding. That is for sure. Okay, so the grading policy is here. In the 3 terms. For the first term, there are 4 rubrics. Okay, the group proposal you'll get 2% marks. Okay, you can see total 100%, right? So 17%, since the total is 1 credit in the first term, 2 credits in the second term, and 3 credits in the credit hours in the third term. So 6 credit hours total in 1 year. So 17% marks in the first term, 33% marks in the second term, and 50% marks in the third term. So the total is 100%. So for the first term, within this 17%, you can see the group proposal will be 2%. Okay, progress report will be 8%. Logbook or peer review will be 2%, and presentation marks will be 5%. So this is the 17% total. Okay. And all this progress report or the group proposal, that will be checked by the plagiarism checker. So make sure that you are writing your own language. Okay, and for the second term, progress report 15%. Okay, peer review or logbook is 4%, and presentation 14%. Total 33%. And for the third term, the final report is 18%, logbook, peer review or cross-check is 9%, presentation will be 15%, and group demonstration of the project outcome is 8%. So the total will be equal to 50%. The total is 100%. So is it clear to you? So probably those who have not taken, maybe some part are not clear, but those who have already registered in the first, second, or third term, probably these are clear to you, right?
Yes, sir.
Anybody has any queries or questions or clarifications? Need clarifications? No?
Yes, sir. May I ask a question?
Sure. So please write.
So
yeah, please introduce, because I can't see anyone. Just your name.
Yes, sir. My name is Abdur, and my question is, can you kindly explain the logbook and the peer review part?
Yeah.
What do you actually do?
Okay, logbook is basically your attendance of every classes. Okay, if there are 400 classes, regular class or group discussion or whatever it is, so that will be come into place over there. And for the case of peer review, basically this is the form I will show you how to make how to assess or evaluate your group members. Okay, you have to assess or evaluate your group members, other group members. Similarly, the other group members will also evaluate you. Okay, on some topics, on some rubrics. I'll show you that one.
Good. Thank you, sir.
Okay. Any other queries, clarifications?
Yes, sir.
Yes, sure.
Sir, this is Nur Alam Moidun Nabi, and I have a question.
Sure.
I am IEEE 400 third term student. You know, in this pandemic situation, it is little bit complicated to construct the hardware because we have to go to purchase the component from outside.
Yes.
And it is also difficult to meet my friends, meet my group member in this pandemic. In that case, what should I do now?
Yeah, you cannot, at the moment, probably you cannot meet physically, right? That is the problem.
Yes, sir.
Yeah, that is the problem. So actually, IUB was open actually before starting this this lockdown. Okay, and IUB laboratory was also open. So students came actually for their implementing their hardware project in our lab, and that will be probably that will also happen in near future. once the lockdown is closed. So the main thing is that at the moment, probably those who are in the third term and have to implement the project through the hardware, it may be very difficult. But what you can do is that you can implement through the software, okay, in any platform, and then you analyze it. So probably that will suffice the hardware implementation part.
I think
and regarding, yeah, just a minute, yeah, and regarding the you are saying that you cannot discuss each other. This is not true, because we are discussing now. So discussing nowadays, the virtual discussion is easier than the physical discussion, because in the physical time, normally you have to go to you have to travel a long way to meet each other. Okay, at the moment you don't need to move. Okay, you just stay at your table and you can discuss with your group mates. Yeah, Dr. Mustafa, carry on.
yes. Sorry. I think we have to, for hardware implementation, we have to be keep in mind that we are assuming that lockdown will be done by Eid time or something like that. But in case it's not, because it all depends on how the course of the COVID pandemic takes place, and there's a possibility that during Eid time a peak can hit. So in that case, we have to especially for students who are doing hardware implementations, that might have to be revisited, how to actually accommodate their
final project.
Yes, because
final implementation.
Because all this Indian variant of the COVID, if it does come to Bangladesh properly, that the time for expression is around Eid time, mid-May. So things can go worse, possibly not hopefully not. But in case it does, lockdown might be continuing for a longer period than we had initially expected.
Okay, if you have any question in the chat box, Dr. Mustafa, would you please help me to read those, because I can see, because I am using the whole presentation mode, so that's why I can see any.
Yes, so far no question. There's only 3 comments in the chat box and no questions yet. One question was if this session is recorded, and we are recording it. So we are
recording, and that will be uploaded. Yeah, that will be uploaded and will be available in the IEEE website for future references. Okay, is there any question regarding here these marks distribution and assessment tools? Okay, if not, then I can proceed on. Okay, actually, I'll talk this one later on about the mapping of the knowledge profile, complex engineering problem, and activities. I'll talk details about this. And then organization of the report is here. Of course, report template is already there, and report sample is already there in the website. So it just go and download that and follow that in order to write your report. And of course, you have to read this manual very carefully, because everything is written A to Z here. That what will be the margin, the page size, line spacing, okay, paragraph indentation. So everything is written very clearly, okay, and how will be organized the preliminary pages, okay, the logo of the university, the name of the university, title of the project, student's name, ID. So everything is written here very clearly, okay. There will be declaration page, there will be approval page, okay, there will be acknowledgement page, there will be abstract page, table of contents, list of figures, list of tables, okay. So and then the body of the project, how to write it, how to write the chapter, what will be the chapter title, and what will be the size. So everything is written. So please go through all these things and follow these, how to write the table captions and the figure captions, how it looks like. So everything is given here as an example. So follow this, how to write the references, how to refer these to the to cite this to the main text. For example, the journal articles, how to cite it. So conference proceedings, dissertation or project, internship report, or any other report, books, book chapters, okay, electronic resources, for example, for the website, okay, for other company or organization reports, how to cite it, how to refer it. This is completely written, okay. And for the appendices, you know how you have to put it at the after the references, and everything example is given in the sample, okay. But how about the hard copy? So for the hard copy, basically the hard copy cover, we have a top cover and we have the side cover. So look at this top cover. In the top cover, we have this logo, Independent University. The title is there, the author 1, 2, 3, that is student's name, and then department, and then your term. And then you can see the side is UG is here. That means the undergraduate. The title will be text. Alignment is something like this. Then the author alignment title, author name will be aligned like this, and then the term. Okay. So these are the end of this IEEE 400 manual. Okay, then if you don't have any question, then I will move. If you have, raise your hand or open your, unmute your mic and you can ask. No?
Sir?
Yes?
Sir, the titles and the names all will be done sidewise, like the ones you showed.
This is the top cover.
Yes, sir, that's clear. I was talking about the second cover.
Yeah, this is the not the second cover. This is the side of the book.
Oh, side of the book. Oh, okay, sir.
Okay, you can see, you understand now?
Yes, sir. Yes, sir.
If you put in the bookshelf, then you can see this one.
Okay, sir.
Yeah? Okay. Any other question? Okay, no. Thank you. And then I'll move to the second one, that is the applications. Okay, so from the very beginning, those who have already taken or you want to take, go through the IEEE 400 manual once again. Okay, and read this manual at least 3 to 4 times. And then this is the applications. Okay, this is the applications. Finally, a design project application. You have to submit it to your supervisor first, and then the supervisor will submit it to the department. Okay, once your supervisor will agree to take you in his or her group, then you can proceed on. Okay, that's why you have to submit it. Okay, those who are in the first term, if you don't submit it, you submit it today. Those who will take in the next term, you can submit it before starting the semester. That means you have to submit it now to take the approval from your supervisor. Okay, for example, from the next term, you just click it here, the summer 2021, right? And then write your name, ID, email address, and the phone number, and the proposed supervisor name. Okay, and his or her designation. Okay, then academic records. The supervisor will want to know the academic records of the students and his or her experiences, because you want to study you want to research on, for example, in telecommunications, but you didn't do any telecommunication courses until now. Okay, so that's why we have to cross check. So write your name and then credit completed until the last semester. Until the last semester, don't count this semester. And then credit enrolled in this semester. Okay, then we can understand whether this plus this should be 100 minimum. And then your CGPA. And then to understand whether you have that minimum knowledge on this area, we want to know these things. Tentative project title, probably you don't know at the moment, at least write your area. If you fix it, your tentative project title, okay, you can write it. Otherwise, research area is fine. For example, telecommunications, okay? You can precise it. Okay, very precise it. Okay, for example, you write power and energy. Instead of that, you can write the power optimization, power system, or fault detection, or for example, power electronics or power converter. Whatever it is, you just write it more specific instead of writing the area only. Then student name. You can say you have to write, for example, if you have three students in a group, at least 2 courses per students. Okay, you have studied so far relating to this area you have proposed here. Okay, student names, then course code, then course title, then semester, and the grade you got. For example, C plus or A plus, A or B plus, whatever it is, you got it. Then student's signature and date, and then you submit it to the supervisor. Once the supervisor is approved this one, then he or she will submit it to the department, and the department head will approve this, and then you can proceed on. So this is your first duty. Before starting the semester, you have to submit this one. Okay, so those who want to take in summer, submit now. Is it clear? Any question regarding these applications?
Sir.
Yes. Yeah.
Evelina, you can go first. Sir, I was asking if I'm applying for the next semester, which is summer, then
Yeah.
credits until the last semester, does it mean this spring or last autumn?
No. This is last autumn, because spring you don't know. Okay.
Sir, spring I do know, because when I registered, I do know how many credits I registered for, right?
No. The credit you registered, but you don't know the grade. Oh, you mean here?
Yeah, here, sir. That's what.
Yeah,
I meant.
here you can write. You can write.
So up to spring, how much?
The CGPA you know until now, you just put it. Okay.
Okay.
Until the last semester, right? You know the CGPA until the last semester. I'm talking here about. Okay. Yeah. Someone want to ask another question?
Sir, my name is Sabrina Nurhan Hassan. Sir, I wanted to ask in the third section here, sir, if we enroll under a supervisor where our research will not be related to any of the courses we did so far.
For example.
For example, sir, I am planning to enroll under Dr. Mustafa Habib.
Yes.
So the research that he does, it's not really related to any of the courses we did.
Sure. Are you sure?
Well,
okay,
sir, photonics.
I'm giving floor to Dr. Mustafa.
Actually, there is IEEE 313, which is your electronic fields and waves. That's one course. Then, if you have taken a course on renewable energy, is there anything on renewable energy or power electronics or something like that?
Power electronics are there.
Power electronics is there.
Sir,
but you have the materials and chemistry.
Yeah,
you have the physics.
Oh, yeah, physics. Yeah, okay. And 313.
Yeah.
Okay.
So there are a lot of courses. So you can't say that any research area is of course fall in many courses.
Okay, sir. I wasn't sure of the direct relation. That's why, sir. Thank you very much.
So for you, physics, IEEE 132, which is materials and chemistry, and IEEE 313, which is EM waves, and
you have to write only 2 courses, right?
Oh, okay, great.
That's okay. Thank you, sir.
Very relevant 2 courses. So 313 and 132, you just put these 2. Okay. Any other question?
Thank you very much.
You are welcome. Any other question? Okay, I'm sure this is clear to all. Okay, then I'm going to show you the next one. The next one will be the research proposal, project proposal. After the applications, the next thing you have to propose it, right? Okay, so this is the final year design project proposal. once your title is tentative title is fixed, that may be changed during your project implementation. Until the final semester, you can actually change it, but you can fine tune and so on. But once it is the tentative title is fixed, then you have to submit your project proposal. So once again, you just put it, for example, summer and then 2021, okay? And then you write your name, ID, email address, phone number, supervisor name and designation. Make sure that you are writing correctly. Okay, don't write the wrong thing over here. Then the tentative title of your project. Then you have to write the background and motivation, why you want to do, why you want to pursue your project in this area or with this title. What is the background behind this? Okay, why you are motivated. So you have to write it in the second section. Then what are the objectives? That is objectives of your project. Okay, just bullet point 2, 3, 4, 5, whatever it is, your objective. Make sure that you have to implement after implementing the project. Okay, the goal is with these objectives. And then research methodology and implementation or validation. You have to write it, the research methodology, very clearly, starting from the literature review until the implementation of or validation of your project, step by step. Okay, the sample is already there, by the way. And then describe how the project addresses the complex engineering problems. I will discuss this because without this you cannot proceed on. So just left section number 5, and then you have to write your budget for implementing this project. Okay, so this budget for the first and second term, or even the last term student who have already completed their project, that was slightly different. So now we are saying that this budget is actually, if you are an engineer, so how to implement an engineering project. So you have to think in such a way. So although this is a very small project, but this is an engineering project. So you have to you have to write your budget from that bear in mind. For example, the project planning cost. Okay, project planning cost. For example, project implementation cost. Okay, that will include, for example, project planning cost means you may have some for example, some external, or for example, some consultant or something else. For this project is not necessarily, but for implementing a real project, what is needed, you have to write it. Okay, and then for example, the project implementation cost, that will include the cost of, for example, the component cost, the for example, simulation, hardware, prototype building, testing. So all these things will come into place. For example, the human resource cost. Okay, for example, some other cost. Okay, to practical for marketing, or for advertising, whatever it is, or everything should be included in these things. So you have to write this budget in a real project. And then in another table, you can write a budget to implement in your project, where, for example, no planning cost, no human resource cost, no implementation cost. Even implementation cost means only you can take, for example, the cost of the components and related resources. Okay, so no human resource cost, so everything is free over there, right? So in another table you can write that one. Then we have a knowledge that how to implement an engineering project. Then we have a knowledge of how to implement our small project as a prototype. Then you have to have a work plan. Okay, the first term, second term, and final term. You have to write it, what you will do, how to implement your project, how to complete your project, not the real life one, your project, starting from submitting your research proposal until the implementation. Okay, first term what you will do, second term, third term. So sample is already there by the way, so no problem. So expected outcome of the project, what you are expecting after at the end of your project, what are the outcome you are expecting? Okay, write it very clearly. And initially you have set some objectives and the outcome you are expecting here. Okay, that should be aligned with. Okay, but finally maybe there will be some discrepancies. You have to write in section 9 the impact of the project on the society, on the environment, and sustainability. Whether your project has any societal issues like any health issue, like any cultural issues, any legal issues, or so on. And similarly, you have to write whether your project has any environmental impact, or for example, you have finally the project is sustainable or not, both in technically and also economically. Okay, so with this you have to submit it with your signature to your supervisor. The supervisor will sign this one and submit it for the grading. So any question regarding this final year design project proposal?
This is supposed to be submitted by the end of the first term, right?
Exactly.
Okay.
Exactly. So this one will submit first. Second, they will present their progress report. And third, they will submit their progress report. Okay, any question regarding this project proposal? Yeah, except this number 5. Okay, addresses the complex engineering problem. I'll discuss this. Okay, if not, then
Sir, I have a question regarding this and the previous section you explained. Sir, if we work under a supervisor from a different university alongside one of our own, do we have to submit progress reports to both the supervisors? Do we have to follow the format for both IUB?
No. You are doing project at IUB.
Yes, sir.
Okay, so your main supervisor is from IUB, your co-supervisor from somewhere else. But you have to take permission from the IEEE department first.
Okay, sir. Thank you, sir.
Yeah, if the department agrees, then you can proceed on. But you have to follow all the guidelines provided the IEEE 400 manual at IUB, not the other university, or not the other institute, or not from the industry. Okay?
Yes, sir.
Any other question?
No.
Okay. Yeah, someone? No? Okay. If not, then I am going to the next one. That is the first term progress report. First term presentation first. Okay. So the presentation template of the first term. Okay, hope you can see this, right?
Yes.
Yes, sir.
Yes, sir.
So you can see this is the template available. So you have to follow this. So the at the top, whatever we have, just left as it is. Okay. Here you have to write your title of your project. Okay, 36 points, Arial bold centered. It is written. Actually, you just write over here, and that will follow. And then presented by, if you are 3, then presenter 1, 2, and 3. The name of the presenter is fine. And then you have to change it, the supervisor name here. So left this 2 line as it is. And here you have to change it. For example, you have to change the page. For example, we have 17. If you have 20, then make it 20. You have to write the presenter's short name. If you are 3, so write the, for example, last name, first comma, second comma, third, last name, okay? And then short title. If the title is wrong, you just write few words and then ... You can understand the title of your project. Then outline is more or less is fine. If you want to change it, okay, discuss it with your supervisor. If he or she agree, then change it. Otherwise, you have to follow it. Then background and motivation, it is written that use a page or 2 to state the background of this project. Okay, don't write so many words or sentences over here, preferably either pictorial or using block diagram. Okay, people understand the images, people understand the graphics, people understand the block. Okay, you have to write it here why you are motivated to pursue this project and its background, 1 or 2 pages. Then come here, you have to fill this table, the literature review portion. So you have to review the literature to pursue your project. For example, you have reviewed 30 literatures, preferably from the journals. You can go through the conference proceedings. You can go to through the books or book chapters, or for the online materials, but preferably in journals. Then we don't need to accommodate all these things over here. For example, 20, 30 papers, you can accommodate, for example, 4, 5, or 6 within these 2 pages. You have to write the reference name, conference or journal or book papers. Then, for example, the outcome of this paper, what are the limitations or problems of challenging issues find in these papers, and what will be the possible solution, for example. Okay, then you write it down in such a way. Then follow this. After this literature review, the following major problems are discovered and need to be addressed. So list it, for example, 1, 2, 3, 4, whatever it is you want to like. And then how many of these problems you want to address. Okay, that will be your objectives. So put that objective over here. Okay, the objective of this proposed project is this. Make sure that if you write 1, your target is 1. If you write 2, your target is 2. If you write 4, means your target is 4. Okay, how many of these you can implement, we can see after 1 year. Then this is the example of the research methodology. This is also needed to put in the research proposal and also the progress report. Okay, this is a typical example that the literature review of design using PSIM or simulation. You may have some other step, for example, the theory or simulate some other design methodology. And then maybe simulation. Okay, then for example, the making the hardware prototype and testing it. Okay, perform the experiment and testing it in the laboratory, and then you got the result and analyze the result, and then you can compare with this result with simulation and experiment. You can compare your result with the existing literatures. Then you have to have a very precise proposed system with a block diagram. Okay, starting from the input to the output. Okay, so you have the input, you have the process, and you have the output. Okay, you have the system and you have the output. So follow this. This is one of the example over here. So just like this, you have to draw a block diagram precisely for your proposed project. This is the work plan, as I mentioned over there. that in the first term, probably, this is an example, by the way, okay? So you can write it in a different way, no problem, okay? Your supervisor will check it. Then, for example, in the first term, problem findings, literature review, and solution progress, proposes. Then, for example, the progress report submission and the presentation, okay? In the second term, for example, the simulation implementation and testing and analyzing the data using this simulation, and the progress report submission and presentation. And in the final term, for example, building the prototype, hardware prototype, and testing it in the laboratory, and for example, analyzing the data, laboratory data. Okay. Finally, you have to submit the final report, and present it. And of course, there is another process here, is the project demonstration. Okay, that you can write here. This is the slide. You have to write it very precisely, the expected outcome of the project. Okay, what you are expecting after implementing this project. Then impact of the project on the society, on the health and legal issues, and then impact of the project on the environment and sustainability. As I mentioned earlier, you have to write these 2 slides very carefully, okay, because marks will be given in these 2 slides. Okay. The proposed budget, as I mentioned in the proposed slide, that this is the realistic project. You have to write it, and you can make another slide for this part only. So this is the realistic budget for an engineering project. For example, project planning cost, how it looks like, human resource cost, okay, hardware component cost, project implementation cost, or project report cost. Finally, okay, other cost you can think of. This is just the example. So go through the literature, go through the website and search it, how to implement a project and how to prepare the budget for implementing a real engineering project. So you have to have that idea. Okay, so you write it, and the justification, you have to write it here, why this is necessary, why this money is necessary for this. This is very important. If you can write this in a proper way, actually that will be very helpful in your real life as an engineer. Then addressing the complex engineering problems. Okay, I will show you with examples. Okay, these are the problems, attributes you have to consider. There are 7 problem attributes. The first one is the depth of knowledge required, and the last one is the interdependence. Okay, the practice is from your project. Okay, the problem 1, the addressing the problem attributes 1 is a must, and from 2 to 7, minimum 2 and maximum the rest of the 6. Okay, so that means all 7s can be come into account or not, but at least P1, and from P2 to P7 minimum 2. Okay, so I will discuss this later on, and then you have to summarize this. What is the summary of your findings of your first term project or implementation up to now? Okay, you summarize it here. What you have done so far, what you have expected, and so on, and what will be the impact of the project on this, that, and so on, what you have discussed previously. You just summarize it so that within this summary page, everyone can understand. Okay, so then give you some selected example references here, and then the slide for the question and answer. Okay, these are the template you have to follow. You have to follow all these things. You can add things, but you cannot delete from here. Okay, you cannot delete from here. If you delete it, discuss it with your supervisor before deletion. Okay, if your supervisor agrees, then you can. If your supervisor doesn't agree, so it cannot. You can add. Normally, the best practice is to go up to 20 slides. Up to 20 slides. Okay, not more than that. That is the best practice. Any question regarding this template? Except the complex engineering problem.
So this is Sadiq Abdul. I had a question regarding the budget.
Yes.
And I also wanted to know, should we implement scalability or marketability of our actual product into the presentation as well? We have a portion about scalability. How can we scale it up or actually transfer this into a more marketable option?
Yeah, because this one will also, you have to write in your report. Okay, so in the report you can write in details. You can write in details.
And for the proposed budget, should we have two separate budgets? One for the field product and one for just IUB? Since we will not be actually getting any human resource costs or project planning costs.
I explained.
Yes, sir.
Yeah.
So there will be two project budgets in the presentation as well.
Here, yes, you can put it. You can put it, but that will be a good practice. This is the real budget for a real engineering project. How to implement a real engineering project, and for example, the other one is just only the hardware component cost, for example. Because in some cases, for example, if it is the simulation based, so someone says that, sir, we don't have any cost, any budget, right? That is not true. So for them, they must have to fill this table.
Okay, I just want to add just a minute. This is Professor Khusru. So yes. Just I'm answering Sadiq Abdul's question. So you actually, this budget is the developing cost of the project that you are doing, right? This is just the template, but scalability, marketing, I think there's a different after developing this one, that budget would come later. I think you don't need to include that one here. This is just your project developing cost budget, I think. You understand, Sadiq?
Yes, sir. Thank you, sir.
Yes, actually, I told them to understand both. Okay, so this one is what in this table you can see. This is actually how the real engineering project is implemented. And in another table, you can put it just the implementation of your project. Okay, which actually has no cost for the project planning, which has no cost for the human resource or project report or other cost. Okay, but practically we need to in our real life we have to include all these things in order to implement a real life project as an engineer. So we have to have both knowledge. That's why I wanted to, in your report, you just put all these things. Okay, maybe it is not possible at the moment to understand these things very clearly, but you have a very preliminary idea. The scalability is not possible at the moment probably for you. Okay, thank you. So our head of the department, Professor Khusru M. Salim with us. Thank you very much. And if you don't have any other question, I can proceed on. Yes, students?
Yes, sir.
Yes, sir.
I can proceed?
Yes, sir.
Yes, sir. You can proceed.
Okay. So the same thing will come into in the second term. The second term, only the difference is in the second term. Okay, the difference is here. The second term, you have to include your theory, design, or mathematical model, whichever suit in your project. You just put say for example 1, 2, 3 slides. Okay, and in the second term also the simulation or the experiment, whichever applicable for your project, that will come into account here. So put that one, and then the result and analysis. If it is simulation, then the result and analysis of your simulation. If it is experimental or the prototype you have already ready, then you can put it here. You analyze these things. And once again, the complex engineering problem is the same as the first term. You put it here because in the first term probably maybe you did some wrong. You have some wrong conceptions or idea. Then finalize it once again. And then this one is the new thing. You have to address the complex engineering activities. Okay, so that will come into place here. So make sure that these two are correctly written or comprehend over here. Okay, and summary and the other thing is there. So the only thing is the simulation part, and if you have any theory or design or the mathematical model, so that part will be included in the second term. And for the final term is actually this is the presentation of your whole project. This is the project, whole project. Okay, so that means this will start from the outline. Okay, then background, motivation, of literature review, problem statement, objectives, proposed system. Okay, everything is there. And then complex engineering problems and activities, this will be brushed up, and then the final version should be here, and that will be reported in your final report. Okay, then theory, design, mathematical model, whichever applicable, you just put it here. The simulation, of course you have the simulation, so put it here. Okay, then if it is hardware, you are building the hardware, the component needed or used for building the hardware, so write it down. And then a hardware prototype. Okay, the picture of the hardware prototype and testing, preferably in picture. You may show the video presentation, no problem. And then the result and analysis, both of the simulation and then from the experiment. Okay, so you have to show the result and also analyze the result very carefully, and you have to show the impact of this project outcome on the environment and sustainability, and you have to let us know the limitations of your project, and then finally you have the conclusion of your project. This is the conclusion of 1-year project. Okay, then you have to guide for the future students that the future scope, because you have some limitations, so they can overcome those limitations. So put it here, what you have done, what you have not, then put it here so that the future students can carry on from your report. Okay, so that's the case for the final report. So any question regarding this second term and the final term presentation? Yeah, especially the students who are in the final and second term. Is it clear to you? Because I will jump into the topic of complex engineering problem and activities. And then we have to wrap up. We have started in 3:14, so 4:45 I'll finish. So no question? Everything is clear to you?
No, sir.
Yes, sir.
Okay,
Yes.
that's fine. Excellent. Okay, we have discussed so many times, probably for you guys, probably for the first term students, they have some questions, or the students who will check in future. If you have any questions. No? Okay, thank you very much. Then I will jump into the complex engineering problems. Okay, once again, I'll go to, okay, before that, okay, course outline. Okay, so each and every faculty members will actually provide this course outline on the very first class of your 400, or that will be posted in the Google Classroom. Okay, this is the 400. So the objectives are there. So there are so each and every students, please go through these course outline, because there are course outcomes which are related to the program outcomes, and what are the weights of the grading, okay, of total 100%, and what are the Bloom's taxonomy we are using, and then the teaching learning methods and the assessments. So everything is written over here in this table. So please go through this table, and then I have already discussed the grading system in the manual for the first term, the group proposal, progress report, and logbook or peer review, and the presentation. These 4 topics will be graded. That means 2%, 8%, 2%, and 5%, total 17%. And in the second term, progress report, peer review, and presentation, 33%. And in the final term, the final report, cross-check or peer review or logbook, and presentation, and project demonstration. So total 50%. So this is total 100% marks. And then about this one, okay, there will be some weekly plan for 400 first term. This will be the contact hours will be 26 hours total. Okay, 2 hours per week. This is the 4 hours per week in the second term. That means this contact hour includes the course offered by the faculty members, or that is supervisor, as well as to the group discussion of the students. So make sure that you have a group discussion among your group members. And this is the 4 hours in the final term. Then there are some rubrics on how we will give marks, okay, to the first term, second term, and the third term. Okay, in the first term, actually, we, as I mentioned before, that this will be graded 100% in such a way: 70% in the first term, 33% in the second term, and 50% in the third term. So rubrics are also here. So this will be provided to each and every students. So I have already completed this one, and I will disseminate to all the faculty members this one, and they will actually disseminate to the students. Okay, normally I did not post, we cannot post this one in the IEEE website. That's why, because this is very confidential. There are some these rubrics. Okay, so how we will marks? Just I will give one example. For example, here. Okay, the presentation marks. Okay, look at this final term report or presentation rubrics. How we will give you the marks? Okay, so this is the first one. Look at this one. The first one is the identify a contemporary complex engineering problem whose solution can be designed, developed, and verified. So here, the faculty members will give you the marks either 1, 2, 3, 4, or 5, and then they will scale up it. Okay, so the first one says the novice, okay, and the last one says is the advanced level. That is, you have completed, and for example, the awareness or base level knowledge you have. So very novice level. And then you have the intermediate level, and then we have 2 transition level. So intermediate means apply the concept to somewhat extent, okay? And this is the advanced level, okay? Intentional and effective applications. So in such a way, the marks will be provided. So I think if we provide this to each and every student, they can understand how they will be graded, okay? For example, the literature review, this part. So the beginning and accomplished. For example, beginning, that is, you will be given 1 point out of whatever it is, okay? For example, if it is 10 point, then if you are getting 4, 4 means 10. So similarly, 1 means 2.5. So in such a way, will be graded. So if it is beginners, for example, literature review is incomplete and or omits important research findings, okay, includes excessive discussion of related issues, okay, significant errors in content. So these are the things, if we find, then you will be graded as, for example, 0.1. Okay, and how about this one, 0.4? Literature review is complete. Sufficient detail is provided to support assertion. Okay, assertion supported with evidence, and then includes original and relevant insight and analysis of the topic. So there are two intermediate also, okay, developing stage and competent stage. So in such a way, you will be graded. Okay, so before joining each and every classes, at least once a week, you should go through this course outline. Then you can understand everything. Regarding the complex engineering problem, I will start this one here. Okay, complex engineering problem and activities. Okay. So finally, a design project is actually will touch the each and every program outcomes. Okay, at the moment we are touching program outcomes 2 to 12. So what are the knowledge profile? Knowledge profile actually we will includes all the knowledge profile in finally a design project implementation. Okay, but you can see that we did not give tick mark on the natural science and mathematics, because natural sciences like physics, chemistry, or for example the mathematics, statistics, probability statistics, algebra, calculus, whatever it is, these are the tools. So natural sciences are the base of engineering and mathematics are the tools of engineering. So these are actually prerequisite. So that's why these are automatically there. So we didn't actually give tick mark. Look at this one, starting from the engineering fundamentals, the knowledge 3, knowledge 4 is the specialist knowledge. Fundamentals means, for example, DC circuit, AC circuit, okay, electronics 1, whatever the course taking, the first course you are coming to EU, is actually you can consider as the engineering fundamentals. And from the subsequent courses and the higher order courses, for example, control system, for example, power electronics and drives, for example, power system, electric machineries, power conversion, whatever it is, digital signal processing. Okay, these are the specialist knowledge. Okay, so of course, what are the knowledge required in your project? You have to know very carefully. Fundamentals, of course, you need, and then specialist knowledge. So as Sabrina probably asked the question that we don't know which are the courses actually match with our research project. So the engineering design and of course we have the knowledge we have to have, and then the next one is the engineering practice, that is the technology and the applications of this design knowledge. That one is the 6. And the 7 was the comprehension. Just like if we are presenting today, if I cannot present it very clearly to you, if it is not understandable to you, so this is meaningless. Or for example, the written documents over here is understandable or not. So you have to comprehend your what you want to say, what you want to explain. You have to explain very carefully. That is readable to all the stakeholders. Okay, that is the comprehension. So we need the two ones. So for example, for the presentation and for the report, you have to cover this knowledge, right? For research literature, the knowledge 8, of course, this is necessary for each and every project implementation, because before starting the project, you have to find out the problems. You have to find out the solutions. Okay, so you have to go through the literature. You have to motivate yourself, and then you have to before implementing this, you have to go through this literature review. This is literature review is knowledge 8. So after the knowledge profile, we have to understand the complex engineering problem. So complex engineering problem has 7 attributes, starting from the depth of knowledge required, range of conflicting requirements, then depth of analysis required, depth of familiarity issues, extent of applicable codes, then extent of stakeholder involvement and interdependence. Okay. So I'll talk this one later on. So let's go to some example. Okay, let's go to the example. So this is the example. Actually, I'm not sure. We can go to the full mode. Is it smaller?
Yes, sir, it becomes smaller. Now it's okay. Yeah.
Sorry. Okay, it's okay, right? Okay, so look at the complex engineering problems we have just discussed here. Knowledge profile we discussed, right? So complex engineering problem, that is depth of knowledge required. This is the P1. P2 is the range of conflicting requirements. P3 is the depth of analysis required. P4 is the familiarity issues. 5 is extent of applicable codes. And extent of stakeholder involvement, okay, and then interdependence, okay. So I'll discuss this with examples, and then I'll come to the knowledge activities. Sorry. Okay, look at this. This is the okay. Okay, look at this project. Okay. The project is, this is the example which has been actually presented in a training session organized by BIET, okay? So Board of Accreditation for Engineering and Technical Educations. So examples of problems and activities in an engineering project. So what is the project? Project is, a project has been conceived to develop a photovoltaic power-based remote water quality monitoring plan for pisciculture. So pisciculture means we know that the fish cultivation, right? So for fish cultivation, we have to monitor the water quality, and the power will be coming from the solar power, that is photovoltaic power, and then these are the things we have to consider in mind, that is pisciculture has become an important part of economy and source of nutrition in Bangladesh. So this will not only mitigate the nutrition of our people, but also this has a huge impact on the economy. Okay, so the fish yield and that is fish farm and the quality depends on water quality. Okay, as determined by the pH level, dissolved oxygen content, and other parameters. Okay, by the way, these are not actually taught by any courses of us, but we have to be familiar with these issues. Okay, we have to be familiar with the pisciculture also, as a whole, and then fish cultivation, sweet fish water cultivated in ponds and water bodies contributes a significant fraction of growth in our society, in our economy, and the fish production in Bangladesh has more than doubled since 2000. That's why we are getting fish in the market, and it's so cheap. So a continual quality monitoring of water quality and prompt remedial action when needed can increase the fish farm and quality of fish even further. So that is the motivation of taking this project. So we can see this project as a whole. So this is a multidisciplinary project and multiple stakeholders involved over here. So that is a very good project for implementation. So if we look at the complex engineering problem first, what are the problems addressed here? The problem 1 is addressed because Problem 1 was the knowledge. So this project requires a lot of knowledges, starting from the fundamentals to the specialist knowledge. For example, we need the knowledge of design the PV system. We need the design of embedded system with sensors. We need the knowledge of wireless communication with data storage in the cloud. We need the knowledge of the integration of subsystems, and we need the knowledge of physical implementation and testing. So we need actually all the knowledges from K3 to K8. Okay, K1 and K2 physics and mathematics, or physics, chemistry, and mathematics. So these are obviously coming to place, coming to account. This is as a prerequisite. So we don't need to mention that one, right? So P3, problem 3 has been addressed because problem 3 was depth of analysis required, right? So we can see that there is no unique solution. There is no unique design. There are multiple correct design. So you need that depth of analysis to select a specific solution, to select the optimum solution for you from many alternatives. And you have to justify your choice. Okay. For example, you have 3-4 choices. You can implement this, for example, by using Raspberry Pi. You can consider that, yes, it is expensive. Okay, why not go to the Arduino Uno? Okay, or Arduino Mega, or Arduino anything. Then, for example, you say, okay, you can implement this one by using the microcontroller, PIC, or any other thing, something like this. Or you can say, no, I don't need anything. We can go use some component, and then you can use it. Then you have many solutions, right? So then from this solution, you just make a single solution, select the single solution by your choice, by your best judgment, okay, and justify your choice, and you just start to implement. Maybe you are wrong after first implementation. Maybe you are wrong that, oh, this is very difficult, so I have to change my selection. So go to the alternative number 2 or number 3 or number 4 and so on. So you have to have this depth of analysis, this knowledge. Okay. Number 4 has been addressed. What is number 4? Number 4 was what was number 4? Sorry. What is that? Oh, here. Okay. So number 4 was familiarity issues. Yes. So you can see there are many unfamiliar issues over here. Okay. So for example, as I mentioned, that the PC culture is unfamiliar to us. Okay. So for example, the water quality is pH level, dissolved oxygen level, okay, or even the PV system is unfamiliar to us. Then the things what we are unfamiliar to us, which are not taught in the theory classes, for example, in our engineering programs. So those unfamiliar issues you have to be familiar. So here we have many things. Then problem 4 has been addressed. Okay. Then, for example, problem 7. Problem 7 is actually the interdependence, right? Problem 7 is interdependence. Yes, this project has many subsystems. Okay, so we have 3, 4, 5 subsystems. So, for example, we have the PV system. We have the pisciculture system. We have the sensing system. We have the communication system. We have, for example, the data storage system. Okay, we may have some web system or application, mobile applications. So all these components or subsystems, if you don't have any subsystem, for example, you have only one system, subsystem, and that is the system. In that case, of course, you have multiple components that is also related to each other. So the main challenges is actually to embedded this subsystem with each other, and that is the interdependence. Okay, and that is challenging issue. So this has also been addressed in this project. So you have to write in such a way. Regarding the activities, okay, let's look at the activity first.
Professor Razzak, you are going to send us this. We don't have this yet, right?
This course outcome with all these rubrics.
Yes, all of this.
Yeah,
the one,
yeah. Actually, I made it in the last night.
আচ্ছা মানে
Okay.
আমাদের কাছে এখনো পাঠান নাই, right? So far.
Yeah, today I'll send all these things.
ঠিক আছে, okay. আমি খুঁজে পাচ্ছি।
No, then you just disseminate to your students. Okay,
okay, got it. Yes, okay, got it. Thank you.
I'll send you the all of my colleagues to the Word file. Then you just modify your name and the other things you need, and then make it a PDF and send to the PDF copy to the students. Okay, so any question regarding the complex engineering problem, or I will discuss the. Of course, you may have a lot of problems. I give the example. Okay, the other issues also be considered. For example, as I mentioned, this depth of knowledge, then depth of analysis required, familiarity issues I mentioned, interdependence. Okay, so look at this too also. For example, the applicable codes. The code means the standards. Okay, so each and every project has a very good standard. For example, IEEE standard, IET standard, or for example, the ISO standard, whatever it is. Okay, you have the or the code like if you are doing projects on the power system, for example. So you have the grid code over there. So what will be the transmission or the distribution voltage fluctuation, for example, plus minus 5 volt or plus minus 6 volt or whatever it is. There's a grid code. For example, the frequency is plus minus 0.5 so 49.5 to 50.5 and so on. So these are called the codes. So you have to know these codes. So not necessarily the codes of the total implemented projects, but if you have the codes, for example, in your any subsystems, or even you have the codes of any components, you can mention here. Okay. And for example, in the case of stakeholder involvement, of course, we have a diverse people involved, especially the project mentioned here. You need the people from various stakeholders. Okay, for example, from the PC culture, from the PB design, from the embedded systems. Okay. So many stakeholders come into a place, and you just put those parties or stakeholder names over here. Okay, so this can be included here. Regarding number 2, the range of conflicting requirements. Each and every project actually has the conflicting requirements. Okay, so in a very common, in general, basically, for example, you don't make it in general in your project, by the way. So for example, always there is a trade-off between the quality and the price, right? Always there is a trade-off. So you try to find out those trade-off into your project. Okay, so what are the requirements? So you can list the requirements to implement it in your project, and then you can find whether there are some conflicting interest that if you do this, so you have to give something less over there. If you go up this, you have to down over there. Okay, so there is always the impedance matching condition, right? So other than this, okay, impedance matching condition, if you go beyond the, for example, we call the resonance frequency. So up to the resonance frequency and beyond the resonance frequency, always there is a trade-off. So the optimum matching is the resonance frequency or the impedance matching condition, right? So give these things over here, okay, in your project. And the examples already given in the website, as I shown you the example. This is also given in the website. So if you have any question regarding this complex engineering problem, otherwise I'll move to the complex engineering activities and then I'll wrap up. So nobody has any question. Okay, that's fine. So this is very good that everybody understands the example. Complex engineering.
Yes, sir.
Sorry.
Ryan, go ahead. What is your question? Go ahead.
So আমার কোনো কোশ্চেন আছে, আমি ইয়েস স্যার বলেছিলাম।
Okay, that's good. Very fine. Any other?
I think the students need to read the course outline.
So any of my colleagues? Yeah, someone want to say some question.
Sir, second term যে complex engineering টা ওইটা একটু
No, the first term, second term and the third term is the same. The all term is the same. This is not
level of interaction টা একটু স্যার মানে ডিটেইলস এ বা ইয়া করলে ভালো হতো স্যার।
Which one? The complex engineering activities?
Yes.
Yes,
Yeah,
I'm coming. Yeah, I'm coming here. Okay. So, okay, I think it's very nice that everybody understands these complex engineering problems with the example.
Actually, I would like to add something, okay?
Yes, sure.
Yes, actually, during this lockdown, there may be a lot of concern about how we are being held up and all the handicaps we have, what are the things we can't do. So there's a lot of focus on that. So I think the emphasis should be that we should be focusing on all the things that we can do. What are the opportunities we have? How can we make the best utilization of all the opportunities you have? Let us not focus on the negatives. Let us focus on the positives. Let us focus on all the opportunities we have now, and let us make the most of whatever opportunities we have. Okay, that's what I would say during the lockdown. Thank you.
Yes, exactly. Thank you very much. Professor Khan has mentioned a very good point. And some students actually asked the question very early in the workshop that during this lockdown they cannot meet each other, they cannot go to buy the hardware components and so on, they cannot go to the laboratory to build up this one. Yes, we have to think about all these issues, and we, as mentioned by Professor Khan, that make best use of it, whatever we have around us. And we, of course, we have the limitations, and make it the best possible solution. Thank you, Professor Khan. And once again, I will start this one, the complex engineering activities. Okay, so these are the problems we have addressed during implementing this project, and the activities is actually what are the activities we have done during implementing this project. That is the case. So here there are 5 activities that should be addressed. Attributes. Number 1 is the range of resources. Okay. Number 2 is the level of interactions. Number 3 is the innovation, and number 4 is the consequences to the society and environment, and number 5 is the familiarity. So I think we have already discussed some of them. For example, number 5 is the familiarity. So the thing which are unfamiliar to us, okay, us means during implementing the project, that should be noted, and that will be your activity to learn those things. you have to learn the topic which are not covered in our engineering programs, okay, which are maybe non-engineering, maybe cross-disciplinary or something like this. Okay, we mentioned that, for example, the pisciculture, we don't know. So learn these things. So that is the familiarity activities. Okay, you have to mention it out over here. Number 5. Regarding the numbers 4, we have already mentioned the consequences to the society and the environment. Okay, so not only the project, after the implementation of your project, what will be your impact, but during the implementation of this project. So is there any concern regarding the society, health issues, cultural issues, and environmental issues you face? Okay, so you can mention those things also. During the implementation of this project, you actually faces these things. For example, you have some legal issues. Okay, you have to take permissions from for example, you are implementing a project like you are making a big drone. You know that for a particular size of drone, there is a threshold weight. Above that, you have to take permission from the civil aviation. So you have to go to them. You have to explain the things, why you are doing, what you are doing, and then you have to take permission from them. Similarly, you have to take permission from different authorities and during the implementation of the project. So you have to write these activities over here. So is there any health issues? For example, you want to test something, you know that BUET students has already been developed some oxygen concentrator, and this is portable, and that is actually submitted to the Bangladesh Medical Association, and this is now implemented in the Dhaka Medical College. So these are the things that the activities is going on during the implementation process. So the final implementation will come into different one. So the consequences to the society and environment during the implementation and what will be after the implementation, so that you have to mention here. Each and every project has the innovation, okay, if it is the engineering project, that's for sure. So you have to have the activities of this innovation during this implementation of the project. So whatever is the design, whatever is the technology, so you just mention here that of course you didn't innovate this one, but if you want to embed all these things together, you need the knowledge of innovation, how it works, okay, where it works, okay. So these are the things you can mention over here. So before level of interactions, ranges of resources. In general, each and every project needs 4 resources in general, okay. So number 1 is the human resource. Of course, you need this one, okay. So someone says, no, number 1 is the money, okay. Number 2 is the money, for example, right. Number 3 is, for example, the data or the information, okay. And number 4 is actually the logistics, okay, that is the components, devices, instruments, and so on. So these are these 4 are the common. So if you want to mention it particularly, then you can mention it elaborate. Otherwise, make these 4 things over here, and then you just elaborate it in your report. And when you are presenting, you can explain. And the last one is the level of interaction. Okay, someone says the level of interaction. So level of interaction is basically actually depends on the problems of 7. 7 is interdependence. Okay, interdependence of subsystems, interdependence of components. Okay, during implementation of the project. So level of interaction is actually the interaction between the subsystems. Okay, because you have to embed all the subsystems together. Okay, you have to have the knowledge of embedded systems over here. So, for example, you have built the subsystem 1 and you have built the subsystem 2 separately, or for example, some other group member build the subsystem 3, and then you have to incorporate these 3, right? Then once you incorporate 1 with 2, then you saw that your system is not working. Then what you have to do, you have to go back to your both system. You have to go back, right, in the system 1 and also subsystem 2. Then this is called the interaction, okay? And then you have come up with the solution, okay? For example, you have a simulation software. You are simulating a very complex, for example, circuit, okay, or of your project. Then you saw that in some stages you are not getting any output. Then what you will do? For example, in the 4th stage you are not getting output. Okay, then go to the 3rd stage. Is there any output in the 3rd stage? Yes, you saw that there is no output. Okay, go to the 2nd stage. You saw that yes, there is no output in the 2nd stage. So go to the 3rd stage, and then in the 3rd stage you saw that yes, we get the output. So what is the problem? The problem is between the 1st and the 2nd stage. Okay, then disconnect all the 3rd and 4th, then and 1st even, and then give the 1st input, the output of the 1st stage to the 2nd stage, and then just check the 2nd stage whether this is working. Okay, you just troubleshoot. So this is the interaction. Okay, so if you have this, I know each and every project has this level of interaction. So you can write down whether the interaction level is the primary level interaction, or the medium level interaction, or this is a very high level interaction. Okay, that depends on the number of subsystems. Okay, so if you don't have any subsystem, this is a primary level interaction, because this is just the component interaction of the component. If it is, for example, 2 to 3 subsystem, then for example medium level interaction. If you have, for example, 4, 5, 6 subsystems or more, then you can write it is a high level interactions, and then you have to explain it as I explain here. So if you have any question regarding the complex engineering problem and activities, I tried my best to explain these 2 things very clearly.
Sir, I have one question regarding the level of interaction that you just mentioned.
Yes. Yeah.
In addition to what you have said about the interactions between subsystems or sub-circuits, is it possible that since many projects can be interdisciplinary, so there will be an interaction between different discipline and different personnel? So will that be considered too, or only the subsystems?
Actually, that will be the written in the depth of knowledge required. Of course, that's the interaction. And if for example, it is multidisciplinary, that means each and every discipline actually may have the separate subsystem.
Yes.
For example, the example what we have given is the pisciculture system. So it is actually there that the water quality monitoring or sensing system is over there. The PV system is over there. So right. there is a interaction between these 2 subsystems. So of course we can mention these activities over here, that you have a back and forth interactions with this level of parties or stakeholders. You can mention that one also here.
Yeah, so because I work on biomedical engineering, so for example, if I develop or our group develops a particular device, medical device, and then we need to test on the patients or the subjects for clinical trial or whatever. So there is a level of interaction. There is an interaction between human subject as well as with the device. So should we mention this?
Yeah, so we have to mention, because sometimes you have the human robot interaction, right?
Right.
So yeah, human machine interaction, whatever it is. So we have to mention this kind of interaction also over there, and then you can mention whether this is a high level interaction or the low level interaction.
Okay, got it, sir. Thank you.
Yeah, thank you very much. So any queries from our students, or anything want to add, any of our colleagues?
Sir.
Yes.
Sir, I actually had the same question as Kafi sir did, so thank you for that. And another question is that, sir, regarding the familiarity part,
yes,
you said that we have to write about the problems or the questions that we might have in our research, right, sir?
Yeah.
So, sir, the questions that might, the familiarity, sir.
No, familiarity, no. Familiarity, I mentioned that the things which are unfamiliar to us.
Right, sir.
That should be mentioned here, okay? Here, the familiarity issues, that these are the issues, okay, you have to address in order to complete the project. And in the activities, you have to write it that in order to implement this project, we have to go through these things. We have to know these things. These are the activities. So, for example, we have to go through the literature. We have to go through the literature of other disciplines which we are not familiar with us. Maybe some other subsystem. So that should be mentioned. So you just mention here the issues and here the activities. What is your question?
Okay, sir. Sir, I got it now. My question was whether we should talk about the problems that we face during our project, or what could be the future problems. So
No, this is not the problem at all. The familiarity issues is not the problem. Okay, problem
the issues that we might face during.
What are the issues you have to be familiar with, okay, in order to implement this project? That is in order to solve the problems.
Right, sir. Got it, sir. Thank you.
So, for example, if you are electrical engineer, or for example, if you are computer science and engineer, then if you are saying that coding, so this is not the familiarity issues. Okay, this we have to know.
Yes,
okay,
sir.
But this is, if this is a specialized things, then you can mention it. So, for example, you have the basic knowledge of coding, but you don't know the Python, for example. Okay, you mention it, that the Python programming is the familiarity issues, and you mention in the activities that I learned this during this time. Okay, I go through this. For example, machine learning. Okay, so these are the things you can write it down. Okay, the issues and then the activities here. Don't mess these activities with these problems. In the problems, you have to mention that these are the problems attributes we have to address, and how you address, where you address, then you have to write it in the activities.
Thank you very much, sir.
Thank you. You are welcome. So any other questions, queries regarding these problems and activities? Okay, if not, then I think how many of us we are here, Dr. Kafi?
So right now we are half of the initial amount of participants. I saw probably it was a marathon lecture and some people have left.
This is the one and this is the last. So
I found that initially it was 101, and then it comes down to 52 at this moment. So I think it was a marathon of a lecture from you while fasting Very, very kind and nice of you, sir.
No.
Thank you very much.
No, it's all
From
right.
your
I
side.
want to mention that I had another lecture from 11 a.m. to 2 p.m. in another university.
Then it must be a very tough day for you, sir.
Yeah.
While fasting.
So,
Especially,
right.
you must be very thirsty.
Okay. No, it's all right. It's all right. Thank you very much. And,
okay, just Dr. Razzak, thank
yes,
you. I'm here till now.
Yeah.
So nice to see so many students and also so many faculties here. Actually, I believe all of the supervisors that we are supervising our students should know it first, right? And we must have very clear understanding first, because we don't want that the student just within this lecture to know everything, because student will know step by step from his supervisor, right?
Exactly.
So supervisor should know it first, because this is also new for us, because we are implementing these things just for the last 3 semesters, actually 1 year. So we should know it first, and gradually I think student will understand gradually. So no need the student should abruptly understand everything. I don't believe it. Okay, so don't worry, students. So you'll gradually understand all this thing. Okay, thank you very much, Dr. Razzak, for your great effort.
Okay, you're welcome. So someone raise his hand. Madon.
Assalamu alaikum, sir. This is Mohammad Zokunuzum. Am I audible?
Yes.
Sir, I had a question regarding this online presentation during this pandemic. So if we are presenting online, so do you have any suggestions or any advice regarding this online presentation, as we might face some difficulties? Suppose we are having a power cut or certain problems regarding our devices. So do you have any suggestions regarding that? Thank you.
Thank you, Badon. Actually, we have alternative things in our mind, and in the last semester also we did so. Normally, before the presentation day, we will ask you a presentation video to send to the department. Okay, so in case of any network failure, or for example, the electricity problem, interruption, basically we will have that video presentation and we will show them.
Thank you, sir.
Yeah.
But just to add that we prefer you to present live.
Yeah, that is the.
And the second option, second option is the recorded video. So for example, obviously you will be presenting in a group. So if you somehow are disconnected, then your group member can take over. And so you have to be prepared for all these backups. So for example, presenter 1 is somehow disconnected, presenter 2 will immediately take over live, because presenter 2 might be still there, he's online or she is online. Okay. And then eventually if everyone fails, then obviously we have the backup. So we asked all the presenters to upload the video presentation before the presentation days. Thank you.
Okay, any other questions from the students? Okay, just echoing with our head of the department, Professor Khosru, that during my presentation, I also learned something. So this is the case. This is the thing. Okay, this is lifelong learning. So as long as we proceed semester by semester or term by term, then actually this will be clear to the faculty members also. And also this will be clear to the students. So students will present these things, the complex engineering problems from the very first semester. So they will present actually in three terms. So I'd like to request all the students and the faculty members. So please download the forms for the faculty members. That actually they can download from the Google side, Google Drive. IEEE IUB Google Drive. And for the students, please always download from the IEEE website I mentioned in the very beginning. Okay, don't take it from your senior brother or sister, because that will be different. Okay, because every term the forms are changing. Okay, because we are learning and we are actually changing. So from the first 3 semesters, these the topic you can see here, the forms you can see here is different. Okay, so follow these things. So those who are in the third term or the first term or the second term and going to present this semester, so please download the IEEE presentation template, first term, second term, final term from here. And you can see there is a presentation sample also to make your life easy. Okay, and for the poster, please download from here. This is the template, and there is a sample also. So always follow this website and download from here. Can you see this?
Sir, the last two files are not accessible. The last two files, sir.
Project demonstration poster and
template.
demonstration. All others are okay?
Yeah, sir.
Okay, thank you for your notification. I will check it and then I will. I will. Yes, it is not working. I'm not sure. I'll check it and then I will upload this again by next week for sure. Okay, in an urgent basis. So if I think there is no other question, this is recording. We have recorded this one and we will be uploaded. Will be uploaded in our website. Yes, any question?
Yes, sir. Sir, my name is Noba, and this is my first trimester of the thesis final project. So, is there any possibility that there might be an extension for the progress report submission? Since we have our assignments and reports and presentations of courses.
Actually, this is yes. I don't know, Dr. Kafi, we gave them any presentation report submission date?
Yes, sir. We gave them when we planned this date, like this 5th and 6th of May. We didn't have this notification from IUB, notice from IUB that we have to close the semester without taking the exam, and therefore all of them, they are going through this assignment submission.
So
I think we will discuss this.
So, yes,
we'll discuss this.
Dr. Razzak
is here, so he can give us some.
Right, Dr. Razzak. So I think I just talked to Dr. Kafi about this one before this webinar workshop. So what do you think about the changing the time schedule for student this final year design project from first semester to third semester after Eid? What about this one? If you think because
definitely we can do that. Definitely we can do that because every students will get an I grade, right? So that will not impact anything. But the thing is that we have to give the grade before May 24.
Yeah, definitely. So, but before 24,
since they are not, since they are not getting any precise grade, all will get the I grade. So it's possible to take the presentation and also take the report after Eid. It's possible.
Yeah, so I think it is a very valid point raised by the students. So we will re-announce we'll discuss and announce reschedule this. No problem with that. Don't worry about this.
Eid is mid-May, right? Mid-17th May or something like that.
No,
so
May
13th.
May
13th or 14th.
Okay.
Thank you, sir.
Thank you very much. I think any question regarding the workshop? Otherwise, we will stop the recording because then we can discuss something. And before stopping, so I'd like to request our head of the department to say something about this workshop, and then wrap up with Dr. Kafi. Yeah, thank you very much from my side.
Okay, thank you very much, Dr. Razzak, for your very, very elaborate workshop about IEEE 400. Actually, this is the first time, I believe, we have taken last 1 year, it's a 3-trimester presentation.
This is second time.
Second time, right?
Yeah.
Oh, this is second time, right? Last time you have also already given. So very good, and I have seen a lot of students and also faculty members. Initially I saw over 80, I think. Now it's become half almost. But nice to see so many students are interested. Actually, definitely you need to know all these things. Even we, the supervisors, also very new. I mean, about these things. So we also need to learn. And well done. And I hope the students, at least they understand something, and gradually they can inquire their supervisor about if they have some specific problem. Then supervisor can give them answer. If supervisor fail, then supervisor go to the expert like Dr. Razzak, Dr. Kafi, Dr. Firoz. So definitely you will get your right answers, no doubt about it. Okay, thank you very much. So that's all from my part. Thank you.
Thank you, Dr. Kafi. If you just wrap up this.
Yes, sir. Yeah, thank you, Professor Kusu, sir, for your nice concluding speech. And yes, all thanks goes to Professor Razzak, sir, for his elaboration of this final design project and a very informative session. It's a 2+ hour long session. Thank you very much, sir, for your presentation. You have always been inspiring us, the students, the faculty members, everyone, for your hard work. And students, thank you very much for joining, and please keep learning. And I request all the students to download the necessary forms and documents from the mentioned website, and please read the course outline and manual properly before you start your project. Thank you very much. Assalamu alaikum.
Yeah, thank you very much for joining all. Especially, I'd like to thank all the IEEE IB student branch for arranging these workshops, and it was actually the brainchild of Dr. Kafi and myself that we need this one. So this is a recorded session. This will be uploaded in the cloud, and this will be shared from next time. And if we want to learn more, then we can go through each and every documents we have in the IEEE website, as I showed in the download button. So I'd like to thank the head of the department and all the colleagues here, and not but the least the IEEE IB student branch, and also all the students who are present here. Thank you once again.
Thank you very much. Thank you very much to everybody.
Thank you very much.
Dr. Kafi, you can stop the recording.